Math 13 and 14, section IC1, spring 2022, Tyler Junior College. Homework 9.5/9.6, exponential and logarithmic equations. Video 3, another example of different bases. Let's get right to it. I wanted to do an example where the base was an e to show you what happens when you take the natural log of both sides, or even log of both sides, and you can't take advantage of something like natural log of e is equal to 1. First things first, I don't have to isolate the part with the exponential term, because the exponential expression, is already isolated. So I can jump right into taking the natural log of both sides. Or log if you prefer, log. I prefer ln. And remember, we do this so that we can implement the power rule, which says we can take this power and bring it down in front. And because that power is more than a single term about to be put inside of a multiplication problem, I should put it in parentheses. 3x minus 7 times the natural log of 5 is equal to the natural log of 14. Now, in the previous example, in the previous video, that natural log of 5 here was a natural log of e, and it got turned into 1, which made it a little bit easier to solve. Not the case here. So what do we do when this log just sits there obstructing your progress? Well, there's two correct things that you can do here. Number one, you can distribute it and get something like 3 times the natural log of 5x minus 7 times the natural log of 5. Yuck, but at least it gets rid of the parentheses. Another approach is better at the beginning, but not so much at the end. Because the other approach to get rid of the natural log of 5 is to treat it as something that is multiplied and in the way. How do you get rid of something that's multiplied? You divide both sides by it. I'm going to take that approach because it avoids having to distribute the natural log across the parentheses and creating a more congested left side of the equation. But there's a price that you pay for doing the division move now instead of the end. The price you pay is you're creating a fraction now, and you're about to throw stuff over there with it. So let's take this to the next page, and I'll show you how it completes. It's really not that bad if you can just keep up with everything. 3x minus 7 equals the natural log of 14 over the natural log of 5. The problem is I'm still solving for x, so I still have to do moves like add 7 to both sides. And the thing on the right side is a big messy fraction that will not cooperate with anything. I can't combine anything with it. I can't give me an exact value. The only thing I could do is put it in a calculator, get a decimal. So as I'm solving for x, I'm going to start piling things over there on the right side, starting with the plus 7. And then the last move, of course, is to divide by 3. But who do I divide by 3? The whole thing. Let me move all this up a little bit so I can have a little bit of room. If you're wondering why I don't use the top space, you can't see it, but there's a toolbar at the top center of the screen. So it covers up some of the things for me, just not for you. Let me move this back down. All right, if I were to divide both sides of this by 3, then I would just put a 3 underneath the mess that I've made on the right. Natural log of 14 over the natural log of 5 plus 7. Now, some people will balk at this answer. Oh my gosh, look at that answer. I got fractions inside of fractions and logs inside of one. Well, guess what? In this type of equation, these are the types of answers that you will get. And this is the price that you pay if you choose back here to do this division move on both sides instead of distributing. Now, if you're kind of curious, I'm going to show you what it would look like if you did distribute, but I recommend doing this move because it's not bad to have a fraction if you start throwing things around it. If you had decided to distribute, it would have gone something like this. I'll show you both and let you decide which one you like. 3x minus 7 times the natural log of 5 equals the natural log of 14. If you had chosen to distribute, if I can get it to draw, let's try this again. If you had chosen to distribute, the natural log of 5 is just a number, but I can't do anything with it except stick it there. I get 3 times the natural log of 5 times x minus 7 times the natural log of 5 equals the natural log of 14. And now to get the x by itself, I would have to pull off an addition move to get rid of the part that's being subtracted. But be careful, if I add 7 times the natural log of 5 on both sides, it'll get rid of the one on the left. But on the right side, I've set up an addition problem that I cannot complete. So the best thing I can do is write my intentions. I want to know natural log of 14 plus 7 natural log of 5. But without getting out a calculator, that's not going to happen. Let me move all this up. And then I would divide both sides by 3. I lost my x. In a different context, that would not be a bad thing. But in this context, losing your x is not good. All right. And now to get the x by itself, I would have to divide both sides by the thing multiplied in front of it, which is this mess, 3 times the natural log of 5. And therefore, we would get x equals a big fraction with the numerator of natural log of 14 plus 7 natural log of 5 and a denominator of 3 times the natural log of 5. So you tell me which one is the lesser of two evils, this fraction or that one, which by the way are equivalent. Without getting into all the details, if you multiply both sides of this big fraction by the natural log of 5, it would distribute, kill the little fraction, and then you would get that answer. But now I'm really pushing the envelope. So whichever one you want to do in this situation is up to you. If you do run across this situation in a homework problem, you will still be expected to put an answer in a calculator. I'm going to put this one in by calling out what I'm pressing. First, I'm going to figure out the little fraction. Natural log of 14, close parentheses on the argument, divided by the natural log of 5 equals. Now I'm going to add 7 to it and press equals. Now I'm going to divide by 3 and press equals. I get 2.8799. And I get the same thing for the other one. All right, so that's what happens when you take a natural log and the number that you get here that I'm currently circling, actually, let's highlight it. The number that you get here is not the natural log of e, so it sticks around, mucks things up, and is all up in the answer, either in the bottom of a fraction that's already inside of a fraction or scattered all over the place like here.